Hey team, it's Mr. Z, and we're going to continue in our activity, and basically we're going to review transformations. All right, so we've been talking about this generally, but this following expression where it's x to the n, and you can see how it's x to the n minus 1, and so on and so forth. But basically, this is an idea we all understand. It's saying, hey, write things in descending order. So for something that's linear, it would be just x. I can have x squared plus x plus 1. I can have x to the third plus x. I can have x to the fourth plus x to the third plus x. It's all in descending order. Basically, I say, hey, if x is a number, let's say the number 5, then it would be x to the fourth, then it would be x to the third, and so on and so forth. Now, as you've seen, you are allowed to have 0 of something. So it's kind of what makes this like the master code for a polynomial function. It lets this represent every single polynomial in existence. And basically, it's just the idea of remembering that, hey, this quadratic is x squared. But there is also some invisible activity going on. And if you know where this activity is, it lets you draw conclusions. For example, here, I know that the vertex of this quadratic is going to be at the origin. It's that extra little bit that gets you there. Okay, some words. Quartic is what you use for a fourth degree polynomial function. It has 4 answers, 4 zeros. Quintic function is a 5th degree. We are going to be talking about transformations, and you're going to see this a lot. This is, again, like what we were talking about in behavior. This whole unit is formalizing your math speak. We're going to make it so that you can share the conclusions you're already drawing, but using the proper terminology. Okay, let's look at this table. This is essentially what's going on. Now, what you understand before is that f of x is the function. You have to remember, like, this is what we're talking about. So what it's saying is it takes the output, the answer of your function, and you're going to multiply it by something. So here, a is like the number. Well, there's different types of numbers. There's positive values. If I multiply something by 2, so if I multiply 2 times f of x, well, that's going to double it. If I multiply it by 1/2, let's say a fraction, this is going to cut it in half. And likewise, if I multiply it by a -1, as we've explored, this is going to flip it. So if I'm just letting f of x be the generic quadratic 2x squared, half would be a little smaller. So it would be, and then -1 would be the original flipped. So in this first one, when you multiply by a number, you take a number and you multiply it by f of x. Now you have to treat it like a variable in a very specific way. It's a variable that's like more than a bit. Read this as y is equal to a number times f of x. And typically you've been training your brain to separate it, but f of x is all one entity. A of x is that number. What happens when the number is greater than 1? 2x. It's a vertical stretch. A stretch is a word for it gets bigger. Notice what happens when it's a fraction, and specifically a fraction that is between 0 and 1. This is just the inequality to represent the fractional numbers. A fraction is typically between 0 and 1. Notice how it uses the word compression. So really, it's again, you know what this concept is, but these are the math words. This is what you're going to be able to spit out ad nauseum. Okay, when a is less than 0, it's a reflection, no matter what. And then it might be affected by, hey, is the negative value bigger than 1 or between 0 and 1? Okay. For this next part, this is a little harder to understand because the first one is just so intuitive, but it's going to follow the same principles. We're going to have to look at now, instead of multiplying the answer, we're going to be multiplying the input. So all of these are going to be looking at the same thing, but we're going to multiply the input. So what I mean by that is, for the first one, when b is greater than 1, let's just go 2 again, right? B is greater than 1. So it's going to be, we're going to take my f, and what are we going to multiply the x by? We're going to multiply it by 2. So it's going to be a 2x that gets replaced in for all of my inputs. It's like I'm replacing an x with an extra part. This might be a little new algebraically. Now I'm going to have to just simply leave this b. Remember, this is all just one word, f of 2x. Now I have to do 2x squared. 2 squared is 4 times x squared. So notice how it changed. This is going to result in a compression that is horizontally by a factor of 1 over b. If I were to substitute it with a fraction, let's go ahead and say f. What am I going to replace my x with this time? Let's go with 1/2 x. That's going to be 1/2 x. Now, let me clean it up a little bit. This is going to result in 1/2 times 1/2 is 1/4 x squared. Notice here, this translates to be stretched horizontally by a factor of b. And then the other way is when it's a negative number, it's being reflected across the y-axis. And the way we remember that is if f is being multiplied by a negative, it's going to result in a reflection across the y-axis. Here, if I evaluated it, it would just be x squared, the original. Notice, because it's an even function, it's symmetric across the y-axis. That's why it's the same. So really, the idea is that the rules are the same. They're going to be stretches or compressions, but it's about just remembering, hey, if it's being multiplied on the outside, it's going to be a vertical stretch. If it's being multiplied on the inside, it's going to be a horizontal stretch. For f of x minus c and f of x plus d, it's just about the rules as we've kind of seen before. If you add D, you add a number, it's going to cause it to go up. Or if you subtract a number where it's negative, it's going to go down. You can see that if I just literally take a point. If I take the point 1, 2, okay, I want to shift it up 1 unit. Goes up 1. If I want to shift it down, it goes down 1. Likewise, the rule on the inside is if it's being subtracted by a number, it depends if it moves right or left. If C is a positive number, meaning it's going to go to the right one. If it's a negative number, you're going to go to the left one.